All right, in lesson 36, you're going to be graphing rational functions again with a horizontal asymptote, but unlike what you did in lesson 35, when the numerator degree was less than the denominator degree, today we're going to do ones where they are equal. All right, so let's start off with this one here. So we want to analyze the graph, so I actually want to graph that particular function. So notice here that the degree is 2 on your numerator and 2 in your denominator as well. All right, so let's go step by step here. First step, this one particular one's not factored for you. Like I told you, most of the time it will be, but this would be the factorization of the numerator and the denominator. So we start off with x-intercept. So x-intercept is whatever makes your numerator equal to 0. So that would be these two terms here. So that would mean -2 and +2. So you'd have those 2 points. Next would be y-intercept, would be plug 0 in for all of the x's. I would do that in the original equation here. So if you plug 0 in there, and there, you would get -4/4. So that would be 1. So you're going to have a y-intercept at 0, 1. Then vertical asymptotes, anything that makes your denominator 0 that doesn't match with anything in the numerator, and you don't have any matches from numerator to denominator. So you're going to have 2 vertical asymptotes, one here at -4 and one at x is equal to 1. We don't have any holes because we don't have any matching terms. I'll show you a hole in one of the later on examples. And in this case, we're going to have a horizontal asymptote of y is equal to 1. Reason is numerator and denominator degree are equal. So we're going to take the leading coefficients, which in this one would be, so I'd have a 1 there and a 1 there. So these would be the 2 terms that we're looking at because those are the 2 that are squared. That's where the degree comes from. And we would write that 1/1 as a fraction. Well, 1/1 is just equal to 1. So we'd have a horizontal asymptote then at y is equal to 1. All right, so let's actually graph this thing. All right. So we have x-intercepts at +2, -2. We have a vertical asymptote at 1, at -4. We have a horizontal asymptote at 1, like so. And we don't have any holes. And we have a y-intercept at 1 as well. Okay, so first thing, remember, you can cross through a horizontal asymptote. So the fact that I have my y-intercept on a horizontal asymptote is no big deal. A horizontal asymptote's we're concerned about what's happening at the 2 ends, not what's happening in the middle. Okay, so we're going to start with the middle of the graph here because we get an x-intercept right here, and we get the y-intercept here. And because this x-intercept here at -2, that's x plus 2 to the first, it means it's going to cross through at that spot. It's not going to bounce. So in order to cross through there and to cross through there, that means we would have to come from down here, cross through, go like so. All right. At this vertical asymptote here at x -1, that's to the first power again. So therefore, if you remember from the previous couple of sections, that means you're going to go from opposite directions on either side of your asymptote here. So because this one's coming from up, that means this one's going to come from down. So I'm going to come down here, go through this, because again, that's x -2 to the first, so it doesn't bounce at that spot. I'm going to go through and run right along that horizontal asymptote. Okay? And on the other side, because this one comes from down and this was x plus 4 to the first, that means the other one needs to come from up here. And it'll look like so. So a little bit better picture from Desmos. That's what that thing would look like. Okay? There's the first one. Let's go through another one. X squared minus 9 over x squared plus 9x plus 18. So again, factor. But now when we factor, we're going to get something that'll match. I crossed them off, but right now, but don't do that yet. When we get to the holes, that's when that'll actually happen. So you got x minus 3, x plus 3 over x plus 6, x plus 3. So we're going to have an x-intercept at negative 3, not at positive 3 because of the matching. I think I said that backwards. We're going to have an x-intercept at positive 3, not at negative 3 because, again, of the matching right there. You don't ever include the removed factor because it's a hole, not an x-intercept. If I plug 0 in for the x's, I'd have negative 9 over 18, so that would be negative 1/2. So 0, negative 1/2 or 0.5. Vertical asymptote. So again, we got two things down here. One matches, one does not. The one that does not will be a vertical asymptote, so that would be at x is equal to negative 6. So the hole is going to come from an x-coordinate of negative 3, and then I'm going to take the remaining stuff that's not crossed off, and I'm going to plug negative 3 into that. So negative 3 minus 3 is negative 6. Negative 3 plus 6 is positive 3. So that'll be negative 2. That will be your y-coordinate of your hole. So the negative 3 here came from the x plus 3, and then the negative 2 came from plugging the negative 3 into everything else that wasn't crossed off. So there's your hole. And again, we're going to have a horizontal asymptote at y equals 1 because my leading coefficients on those would be that. And when I write that as a fraction, that would be 1 over 1, so that would be 1. All right, let's graph this one. All right. So we have an x-intercept at 3, y-intercept at 0.5, horizontal asymptote at 1, vertical asymptote at negative 6, like so. Okay, I'm going to stretch my graph here a little bit further. And we also have a hole at negative 3, negative 2. So I'm going to put an open circle at that spot there. Okay, so we've got 3 points right here, so we can pretty easily tell where the graph's going to look like come over here. Again, at this x-intercept, it's not going to bounce at that spot. It's going to go through because the original was x minus 3 to the first. Okay, so I'm going to come through here, get to this point here. Don't actually like draw through it. You're going to go kind of past it, so on opposite sides of it, go through this. I didn't draw that very straight, sorry. Go through that point, go through that point, and come and run along the horizontal asymptote. All right, and because at negative 6 here, that was to the first power, that means I'm going to come from the opposite direction. So this one was down, so this one will come from up. You have your picture that looks like that. All right. Again, that's what the graph will end up looking like a little bit better there with a y-intercept there at 0.5, negative 0.5, excuse me. All right, let's try one more. Let's do one that doesn't have a horizontal asymptote at 1 like the last two have. All right, 5x squared minus 25 over x plus 10. So there's not really a whole lot of factoring to do with this one except for the numerator we would take out a 5. So my x-intercept will end up being at negative 5. My y-intercept would be negative 25 over 10 when you plug 0 in for the x's, so negative 2.5. Vertical asymptote at negative 10. No holes on this one because it doesn't match with anything at the top. Now, because this is 5x to the first over 1x to the first as where I would get the degrees from, I'm going to have a horizontal asymptote at y is equal to 5. Okay, so I would plot each one of those things and then fill in the graphs. And this is what that would end up looking like in this case. So there's my 5 right there. There's my negative 10 for my vertical asymptote. Plotted my x-intercept and my y-intercept. And again, it crosses through those. It doesn't bounce at any of those. So I would draw that through over to here. And then on the other side, because this one went down, This one would come up because, again, that's x plus 10 to the first. You would fill in the graph and you would be done. All right, so that is lesson 36, horizontal asymptotes when the numerator and denominator degree are equal. Let me know if you have any questions.